Here we go. I'm with it now. So under angle, it's the angle button. You have a bunch of options, 5, 6, 7, and 8. If
Where's the angle button?
mine's above apps, second angle. So if we do number 5, 5 tells the calculator, find me, if I give you rectangular, find me polar radius. So if I do 3, 4 in rectangular, this button finds you the radius. Now, really, what is this button a shortcut for? It's the Pythagorean theorem button. Isn't that exactly what it is? If you give me a triangle with 3, 4, it gives me a radius of 5. So, again, if I do second angle and I pick 5, what was oh, this one, right? We could do this one? Oh, that was the other way around. All right, well, what if I had, I wonder if it'll do it. No, it won't. Of course it won't. Never mind. If I had 2, 2, it would tell me that the radius is 2.82, which is like 2 root 2. It'll also find you the angle. So depending on what mode you're in, right now I'm in radian mode. So if I do second angle, and this time I pick 6, 6 says, give me the rectangular coordinates, and I will find you the polar angle. So if I do 2, 2, it tells me that the angle is 0.785 in radians. What do you think that is in degrees? Let's see. Times 180 divided by pi. Hey, 45 degrees. So this button right here, what's this button a fancy button for? Yeah, what is it really doing? Yeah, isn't it the inverse tan button? Here are the sides of the triangle, 2 and 2. Find me the angle. So really all I did was I showed you a fancy button for Pythagorean theorem and a fancy button for the inverse tan. But wait, there's more. If you get the, if you have it in polar, like we could do this from Miles. So if we do second angle and we do 7, if we give it the polar coordinates, it will find us Rx, where x is the x-coordinate. Now look, we have to be in radian mode to do miles. So if I type in square root of 3, and then 3 pi over 4, it'll tell me, hey, the x-coordinate to that is negative 1.22. Hey, how cool is that, Miles? Now, it won't tell, but here's the thing, Travis. It's never going to tell you that it's negative root 6. Whoops. Negative root 6 over 2. Like, your calculator's not that smart. So if I ever ask you for an exact answer, I don't think your calculator is going to help you. Are you psyched about that? So you think. All right, so a couple interesting buttons. I don't know. I'm glad I didn't show them to you Friday. Are they going to make tonight's homework totally easy? I don't know, maybe. Or at least you have an easy check now. Is that all right? Do you want to ask a question about any of those buttons? I didn't do, just so you know, tucked away down there under 7 is 8. Whoops. Which is just, hey, if I give you the polar, give me the y-coordinate, right? And all the folks at TI did was do the algorithms for all the things that we already knew. like x squared plus y squared equals r squared, inverse tan of y over x equals theta. Like, that's all they're doing. They're just making algorithm for that. I don't know. I've never been one, so maybe it stinks, or maybe it's cool. Who knows? Maybe, like, you get, like, toys or something, and, like, ping pong table, and, like, all the, like, Snapple you could drink. I don't know. Maybe it's fun. What? What? Oh, yeah. No, a calculator programmer. I wouldn't want to be a calculator. Being an inanimate object does not sound fun. But that was a Mr. Barris joke. That was totally a Mr. Barris joke.
Oh, the roof is coming down in here.
All right, let's take a look at 20 and 21. All right. All right, I have two functions, and they're in polar, and I need to get them into Cartesian. I don't know. This looks pretty hard. Well, let's start with A. R equals 4 cosine theta minus 4 sine theta. What are some things that I know? Like, all right, x squared plus y squared equals r squared. That's one thing I know. Anything else? Sine of theta. And x equals... And I think I know one more thing. Say it again. So tangent of theta is equal to y over x. So somehow I need to, like, put this together and see if I can come up with something. Hey!
What?
This actually leads to an interesting conclusion. What's sine theta equal to?
Y divided by R.
Alright, and what's cosine theta equal to? Alright, so I actually feel like I have a couple things I could do here. Wherever I see sine theta and cosine theta, I can plug in, so I can get R is equal to 4, instead of cosine theta, x over R, minus 4, instead of sine theta, y over R. That's not bad. Except I have, like, all these fractions and stuff. Thought or idea, Evan?
Times everything by R.
If I multiply everything by R, both sides by R, I get R squared over here, and I get 4x minus 4y over here. So that was actually a pretty good idea. It looks a little nicer now. And what do I know about R squared? Okay. X squared plus y squared is equal to 4x minus 4y. So guess what? I have it all in terms of x's and y's now. Isn't that awesome?
Yeah.
Now, I haven't really gotten it to look like anything yet, though, and you're going to love this. I'm going to do x squared minus 4x plus y squared plus 4y equals 0. You can. I'm thinking about something that you're not going to like even more than that. You guys are getting there. You're scratching the surface. I'm just waiting for someone to say it. That's actually a good idea. Do you notice that he always has like the most brilliant like statements when we're all like at a loss? He'll just say like something and we'll be like, yeah, that's exactly it. Monty. He's like really good at, yeah. All right, so that's right. Jen got it. You can complete the square. Nice job. So you can complete the square. And for x squared, if you complete the square, you have to take half of negative 4 is, and then square it. So plus 4. And then to complete the square for y squared plus 4y, half of 4, square it. Okay, now I can't just add 8 over here unless I add 8 over here. So this 4 and this 4 complete the square, and that 8 makes it even. So I end up with x plus 2 quantity squared plus y, whoops, that's minus. It's totally minus, you're right. I don't know what I'm thinking. Y plus 2 quantity squared equals 8. Actually, you don't want to do that. Because you can't just take the square root of each individual term. But, no, I'm actually finished. This is actually an equation that you know from last year.
Oh, point salute?
No.
Circle.
It's a circle.
Oh.
Yeah. X squared plus y squared equals r squared. It's a circle that has a radius of root x. And where's the center of this circle? Yeah, 2 comma negative 2, right? H and K. I mean, come on, give me something like, oh yeah, we did that. Yeah, okay. So I just want to point out, we actually, this problem involved a couple of clever substitutions, right? So like, we saw what sine theta and cosine theta were, so we could plug in. And then Evan said, why don't you multiply everything by r? And then we got an r squared so we can plug in to get this. So we did a lot of clever things algebraically before we even finished the problem. Then after we got the problem, we had to complete the square to get something that looked like something we recognized. It's a circle. So I would say this one actually involved a lot of like cleverness. So way to be clever early on a Monday morning. Nice work. Hold on. If we take something like 21a, I guess, this is going the other way. Okay. What's going on? That did not work. No.
Easy, medium, or hard question?
That was hard. Okay. All right. Well, I don't need. It's x equals 5. Why do I really need to clip it from here? No. X equals 5. What do you know? What do you know about x in polar? What's x equal to? R cosine theta equals 5. So r is equal to 5 over cosine theta, right? You always want an r equals. That's an easy, right? So like one was a really quick substitution in. The other was some really clever substitutions and a lot of algebra. So I think the point I'm really trying to make is that with these going back and forth, they can range from very easy to pretty hard. Yeah, go ahead.
On Thursday or whatever, since we actually have a decent amount of equations we have to learn.
Yeah, you do. That's a great comment that Evan made. There's a lot of equations and things to memorize.
So can we maybe have a day where you don't have to like review it with us, but can you just like jot down the equations? Because like
No.
They've been scattered over time.
Yeah.
Like that would just be like.
Could you just, like,
Okay, so look, just so you understand.
Mr. Ryman gave us passage.
That's great. And what? Hold on.